Section 5.4 Day 2 is on kites. Yesterday we focused on trapezoids, and this one we're going to focus on kites. So we're going to identify the characteristics, and then we're going to use the properties of specialized quadrilaterals to complete proofs, and we're going to classify quadrilaterals with the most specific name possible. So to start off with, we are going to have kites. And kites have two pairs of consecutive congruent sides. So unlike a parallelogram where the sides were opposite of each other, these congruent sides are going to be right next to each other, or consecutive. And then we're going to have diagonals that are perpendicular. So if we draw the diagonal lines in here, they are going to form 4 right angles for our diagonals. And exactly one pair of opposite angles are congruent. And these are the two angles where the different side lengths meet. So you'll notice different sides meet at C and A. That means the angles formed there are congruent to each other. But D and B, those are not congruent in this kite. So they are not congruent. Another thing to note is it does cut the perpendicular, or the bisector that connects the congruent angles. It cuts that one in half. So those two segments are congruent to each other as well. So those are all things you're going to want to note about a kite, which will help us solve for different problems. All right, so next we have some theorems to go through. If a quadrilateral is a kite, then its diagonals are perpendicular. And if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And if a polygon is a quadrilateral, then its blank angles have a sum of blank degrees. And this one is the interior angles. And they have a sum of 360 degrees. So this is true for any quadrilateral. It doesn't even have to be a kite. So anytime we have a 4-sided shape, the sum of the angles are going to add up to 360. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 and the measure of angle 4 are going to add up to 360 degrees. And we know that because if we cut this shape in half, we would have 2 triangles. And each triangle has 180 degrees inside of the angles. So if we have 2 of them, we take 180 times 2, which equals 360. So that's just a little information behind why it adds up to 360. All right, now using the information we've gone over for kites, we are going to solve some problems. So we notice that we have the 2 consecutive congruent sides, and they give us 70 degrees and 88 degrees for the 2 angles. They want us to find the measure of angle T and the measure of angle R. So we don't know what they are, but because they are the sides where the angles where the 2 different sides meet, we know they're congruent. So I'm going to put them each equal to x degrees. And we know the sum of all 4 angles equals 360 degrees. So we can set up our equation, adding all of them together and putting it equal to 360. And if we simplify by combining like terms, we'll get 2x plus 158 degrees equals 360. Then we'll need to subtract 158 from both sides, and we'll get 2x equals, and we'll do a little bit of subtraction over here, 202, which tells us x, when we divide by 2, is going to be 101. And don't forget to go back and answer the question they are asking. So we can say the measure of angle T equals 101 degrees. Oops, I wrote that wrong. And the measure of angle R is also 101 degrees. And that would be our answer. Okay. Our next example, they want us to find all side lengths of the kite below. So again, we know the consecutive sides are congruent to each other. So we already have enough information to identify what each of these equals. We know y is equal to 6 and x is equal to 10. So that one didn't require much work. Now if we look at example 3. For this one, they want us to find all side lengths in the kite below. But you'll notice we didn't get any information about the outside lengths of the kite. So we are going to have to use Pythagorean theorem with the right triangles. And that is a squared plus b squared equals c squared. So we can label each side of the right triangle. One is going to be A, one's going to be B, and the outside length is going to be C because that is across from the 90-degree angle, making it the hypotenuse. Plugging those values in, we'll get 5 squared plus 12 squared equals C squared. And we can simplify this to 25 plus 144 equals C squared. And we'll simplify by adding those together. So it'll be 169. I guess we don't need the degree sign here. And that is equal to C squared. Once we get to this point, we need to use the square root to find out what each one is equal to. Now remember, when we're solving with the square root, we're going to do plus and minus and the value of the square root. So this one is 13. And then we need to apply it to our problem. Because we're talking about a length, we know we are just going to be taking the positive value. So we know that side length is 13, same as the side down here. So now try finding this side length on your own and then press play once you have your answer to see if you got it correct. All right, so when you set this one up, again, 5 can be A, and we'll use 6 as our B value. We would have done 5 squared plus 6 squared equals, and because we already used C, I'm just going to put D squared. And then when we work through this, this would be 25 plus 36 equals D squared. Add them together, and we would get 20, 30, 40, 50, 61 equals D squared. And then we would need to find the square root of that. So let me pull up my calculator. And let's just do, oh, I don't think I did that right. Oop, sorry about this. There we go. So we need to find the square root of 61, which is about 7.8. And that is equal to D. Not that anymore. Perfect. So now that we have both of our answers, we are able to label all of the side lengths of our triangle, or our kite. Still thinking of last chapter. Okay. So sometimes you will need to use Pythagorean theorem in our problems. All right. Example 4. Why don't you try this one all on your own? And again, once you have your answers, press play to check your work. Okay. So for this one, we have these two right triangles right next to each other, and we need to find y. And because we know the top one side length is y, this one is also y down here. So I'm going to do 40 equal to a and 9 equal to b. If you did it reverse order, that's okay as well. So you should have done 40 squared plus 9 squared equals y squared. And we would have got 1,600 plus 81 equals y squared. Add them together, equals y squared. And then you should have taken the square root of both sides. Let me just grab my calculator. I will do the square root of 1,681. And that is going to be 41 equals y. And this one is an exact answer, so we don't need the about equal to symbol. So we know that one is 41. And then on our other triangle, we are looking for x. Again, b can be our 9 value, and I'll make 7a. So we should have 7 squared plus 9 squared equals x squared. That'd be 49 plus 81 equals x squared. And that would give us 130 equals x squared. So we'll go ahead and take the square root of 130. And that is about equal to 11.4. And that's what this squiggly equal sign means. It means about equal to. All right. So if you didn't get those correct, make sure you fix your work and then write down the correct answers. Okay. So now we are going to have 2 more proofs to do before we are done with the notes. All right. So our first proof we are going to complete. We are given that triangle ABC is congruent to triangle DCB. And that is our given information. So I'm just going to highlight these 2 different triangles so we know which ones we're talking about. DC, boom. So there we are. And we need to prove that ABCD is a parallelogram. And there's a few different ways we can do this. We could show that opposite angles are congruent, opposite sides are congruent, opposite sides are parallel and congruent, a few different ways. But the easiest way for this one is going to be showing that the opposite sides are congruent to each other. So in our triangle, the first one was named ABC, and the second one was named DCB. So we can label the congruent sides to each other. We know that AB is going to be congruent to DC, and we can write that down here. And then our second side is BC is congruent to BC. And then, oh, actually, we know that, but we don't have to write it in here. I forgot we are proving the parallelogram. And then the last side of both of our triangles would be CA is congruent to BD. And the reason we can say this is CPCTC, corresponding parts of congruent triangles are congruent, or you could write definition of congruent triangles. That works too. So now that we have shown that opposite sides are congruent to each other, we can now say that ABDC is a parallelogram. And we can say both pairs of opposite sides are congruent. And that implies that we have a parallelogram. so make sure you have that copied down, and then we will move on to the next one. All right, we're going to complete the following proof, and we're given that ABC is a parallelogram. So let's write that down. And they want us to prove that angle 1 is congruent to angle 4. Okay, so we're going to use the angles that they give us, 1, 2, 3, and 4. So the first thing that I notice is that 1 and 2 are going to be congruent to each other because they are vertical angles. So I'm going to write that in my proof. Angle 1 is congruent to angle 2. And we know that vertical angles are congruent. And we know that BD is parallel to AC, so we can write that in there as well. And once we have parallel lines, then we can use all of those angle pair relationships with parallel lines to find some more congruent angles. So let's go ahead and we'll say that BD is parallel to AC. And we would start with the parallelogram implies opposite sides are congruent, or parallel, sorry, are parallel. Now that we have that written down, we know that 2 and 3 are corresponding angles, which corresponding angles with parallel lines are congruent to each other. So we can say angle 2 is congruent to angle 3. And we can say parallel lines imply corresponding angles congruent. And you'll notice that 3 and 4 are also corresponding angles. But first we would need to say that BA is parallel to DC. And we can just add that up here, because we know, given the parallelogram, that both pairs of opposite sides are parallel to each other. And then at the bottom, we can add that angle 3 is congruent to angle 4, because they are corresponding angles. Now we have enough information to say that angle 1 is congruent to angle 4 using the transitive property of congruence. And we would follow the train. 1 is congruent to 2, 2 is congruent to 3, and 3 is congruent to 4, which means that 1 is also congruent to 4. All right, so make sure you get that copied down. Remember, we have a quiz tomorrow on parallelograms, trapezoids, and kites. And don't forget to complete that exit ticket, just so I know if we need to cover any of the information again. The homework is already shared with you, and don't forget it is 5.4 day 2 for the homework today. Let me know if you have any questions. Have a good day.